Just wanted to do a quick video here of the TriggerScope16 running with a demonstrator LED bar. So down at the bottom of the view here, there's a 10 LED NeoPixel strip, and I'm using that controlled by the TriggerScope16 with some custom firmware. And I just wanted to show this as a demonstration. This product will be at ASCB this year, and which is coming up here in December, and you'll be able to see it at the Micromanager booth. Here I'm running Micromanager, and I've got a setup here where each LED represents a different wavelength or different DAC line, if you will. So I've got, for instance, FTSE. You can see the 48 nanometer LED style excitation, and then a white LED which indicates a shutter. If I go to something like Sci-5, you can see that Sci-5 is red and the shutter is white. So the shutter is always equal white, which is the TTL line, and then the attenuated lines, the DAC lines, will indicate the color for whatever channel you're using. Now, if I edit, for instance, this preset here, I'll just open that up, and you can see that I've got selection on-off sliders for each one of my different LEDs, or in this case, my TTL lines. And then I also have attenuation, again, between 0 to 16-bit maximum on the trigger scope, which is represented as the attenuation of these different lines. So I've got some presets made, and you can see that as I slide through these presets, you know, it'll interact with them. Of course, because the presets are made, if I go into a multi-D acquisition, I can run it. Here I'm going to set up, for instance, 5 time points. We'll grab a couple of channels. Let's do 2 channels. Maybe we'll do Sci3 and FTSE. The exposures will be 100 for both. We'll do 5 points, and two second intervals will acquire, and we should see that the channels switch, and then we have a 2-second delay. Now that's all well and good, but this is where the trigger scope really starts to shine, is when we start looking at higher speed situations than this. So we'll close this, and now what I'll do is I'll send a sequence to the trigger scope. So behind me here, I have a text file. This is a simple comma delimited text file, and this text file stipulates what programming I want the system to run in a high-speed sequence. So this is where the high-speed nature of the system really takes off. I can load this file here directly from the Micromanager window. I even have an ability to load multiple arrays. So you could load different files to different arrays and then quickly switch between them. And when I'm ready, I can just hit ARM, and it's going to cycle through all the commands in that file as quickly as it can. And you can see that that's relatively fast. We're running here, I put a 20 millisecond delay, and these LEDs run at 800 kilohertz, so this most likely is time accurate. So this kind of shows how fast the trigger scope can be, and again shows the advantage of using a sequenced acquisition relative to the native acquisition for Micromanager, or really any other program. If you look at my previous posts on program speed, you can see that they're, these software programs are relatively slow, and so with a system like this, you can go a lot faster.